This is pre-problem 14.1. A is CH3, 3 methyls on a carbon attached to a lithium. The metal lithium is considered the parent, and the alkyl group is bonded to a tert-butyl. So it could be called either tert-butyl lithium, or it could also be called 1,1-dimethyl lithium, dimethyl-ethyl lithium, because the longest carbon chain is 2 carbons, so ethyl, and then the 2 methyls are substituent, so it would be 1,1-dimethyl ethyl lithium. So first carbon, second carbon, and the other 2 are substituents. For the second problem, B, it's cyclohexyl is a substituent, and the chloride is named as an anion. So the answer for the naming for this one would be cyclohexyl magnesium chloride. And that's 14.
So this is 14.2. This question is asking for a synthesis from 2-methylpropene, which I've drawn right here, and your result is going to be this right here. The way to do this is that you want to break this double bond to get a bromine first, and then you use that with peroxides, and then you add magnesium with ethyl ether to put the magnesium onto the bond. So it'd be, number 1 is HBr, peroxides, and then your second one is going to be the magnesium diethyl ether, and that's just going to push the bromine over to put magnesium on there, and that's it.
Okay, this is problem 14.3. The problem is asking to use curved arrows to show the flow of electrons. So the electrons from the base, after extracting a proton from it, is going to attack the hydrogen here, and the electrons will then go to the nitrogen. As can be seen here, the H is gone and turned into a conjugate base. The problem also asks for the equilibrium constant K, which the acid pK is 36 and the conjugate acid is 62 for the pK. So in order to find K for the equation, it's going to be the conjugate, or the acid, divided by the conjugate acid for the Ks. So in this case, it's going to be 36 divided by 62. And when you subtract those, you get 10 to the 26. So that is going to be your K.
Okay, so this is 14.4. We have 3 beautiful equations that we're going to go through. So the first one, you have this lithium right here. It's going to come and attack underneath a carbonyl, which is going to push it up. And with the water, it's going to, well, the oxygen is negative charge, so it's going to come and take a hydrogen off the water. And thus, it's going to create this. And it's the same thing going for this one. MgBr is going to come here, attack underneath the carbonyl, push it up. The negative charge of oxygen is going to take a hydrogen off the water, and that's going to create this kind of like a Harry Potter sign. And for this one, it looks kind of tacky, but it works the same way. This ClMg is going to come over here, come underneath this double bond, push it out from the oxygen, and that negative oxygen is going to come get another hydrogen, and it's going to turn into CH2OH, which the CH2 is from here, and then the oxygen just grabs that hydrogen. And that's it.
Okay, the problem is asking for, this is 14.5, the problem is asking for a retrosynthetic analysis of 2-phenyl-2-butanol, which is right here, from benzene and 2-butene. So what I would do to first start this off, you can do many different things, I think, but I would start with the 2-butene and add H2O and H2SO4 with the mercury. Oh, sorry, not mercury. And what this will do is turn the triple bond into a ketone with a carbonyl on it. And then we can work on the benzene ring. And knowing that we're going to have to add, we're going to need to use Grignard to add to the ketone, we're going to need a bromine first on the benzene ring. So you can just add Br2 and light. And that'll put the bromine on the ring. And then all we have to do to make the Grignard is to add magnesium and diethyl ether. And this will create the NGBr on the ring. So now we have the Grignard reagent and the ketone. And basically if we react these two together, it'll create this compound. We react the two together. And what you can do to react those is add in diethyl ether and H3O plus is the next step. The diethyl ether will mix them together, the H3O plus. Once the Grignard attacks the carbonyl, the electrons will go on the oxygen and the H3O plus will protonate the negative charge on the oxygen and create the hydroxyl group on the 2-phenyl 2-butanol.